So we're going to look at the quadratic formula some more, but we're going to specifically look at situations where the answer doesn't look as nice. So what's going to happen is the square root portion is not going to work out to a nice round number. There's going to be a square root in the answer. So what this is called really is an irrational answer. So our answers today will be irrational. Irrational numbers are numbers that make decimals that don't repeat or end. They just go on forever and never have a pattern. Pi is irrational. None of that matters, but that's just the type of number our solutions are going to be. So do it the same way. It's the same formula, right? Quadratic formula. And we first need to make sure our equation is in ax squared plus bx plus c form, standard form, and then just put a, b, and c into the formula. So for this first example, we've got x equals, so the opposite of b, which is 4, plus and minus, square root, b squared minus 4ac, so that's 16, b squared here is 16, minus 4 times 1 times negative 8. Just a reminder here, a is 1, b is negative 4, and c negative 8. All over 2a, so just 2. So when we simplify this square root, or the radical as it's called, remember, we get 16 plus 32, right? 4 times 8, so negative 4 times negative 8, positive 32, over 2 still. Now 16 plus 32 is 48 over 2. And 48 doesn't have a square root. And if you try it on the calculator, you get some decimal, right? It doesn't work out. So that's why we did the first section on simplifying radicals. So we have to simplify the square root of 48. So let's see if 48 has any perfect square factors, and we know 4 is a factor of 48, and that's 4 times 12. Well, 12 also has a perfect square factor of 4 times 3. So we know that 16, right, 4 times 4 here, 16 is a perfect square factor of 48, 16 times 3. So we can actually take the square root of 16, take that out, so it's 4 root 3. So that's what we're going to turn the square root of 48 into. So 4 plus and minus 4 square root 3 over 2. So we change the square root of 48 into 4 root 3. Okay, and if you need help on that, if you're not sure how that works, check out that first video in this unit, right? So now that we have that, kind of scoot that up out of the way here, we're going to simplify a little bit. We can divide everything by 2, but just the coefficient on that square root. Can't actually mess with the square root now. So here x is going to equal 2 plus and minus 2 root 3 and over 1, so that is it. So not the prettiest number, and you could actually figure out the decimal for this. You know, you could take the square root of 3 times 2 and plus and minus that from 2, and you'll get 2 decimal numbers, but this is actually nicer. This is the exact answer without rounding, so this is the way I would say leave your answer in this form. It's also less work. So okay, so our answers, some of our answers may look like this. You have to be ready for that. They may not work out nicely. You just have to simplify as much as you can and leave it in this structure. So 2 plus and minus 2 root 3. All right, next example. First, we're going to rearrange this equation. Make sure it's in standard form. Okay, so 5v squared minus 7v minus 1 equals 0. All right, so we got a is 5, b is negative 7, and c is negative 1. So v equals the opposite of b, which is 7, plus and minus the square root of b squared, so 49, minus 4 times 5 times negative 1, all over 2a, which is 10. So remember that inside of the square root is 4ac, 4 times a times c. There's always a 4 in there. Okay, so v equals 7 plus and minus the square root of 49. It's going to be plus because we have those two negatives. 4 times 5 times 1 is 20 over 10. Okay, so we got v equals 7 plus and minus the square root of 69 over 10. And so v equals, let's think about that, 69. Well, I can divide by 3. That's 23. No perfect square factors there. So that is it. Just leave it like that. All right, so there you have it. Your answers might not look great. Simplify if you can. Otherwise, just leave them alone. Okay, make sure if you have questions, you send an email. By the way, if you ever, and I don't think it happens in this assignment, but for the future, if we see, let's just make a little section here. If we see ever in the square root, as we're working, of a negative number like this, inside the square root, that is a no solution. Technically, it's no real solution, but we can just say no solution. Now, it's okay if you have the negative outside. That's okay. But if you ever have a negative inside the radical, right now that's going to give us a no solution. So if you run into that during your work, check your work. Make sure that it actually is negative. But if you do get a negative inside there, no solution. All right. Good luck.